Okay, today's project is this beautiful Wharfedale SW150 Sub-Woofer. Now these guys are a little bit of a guilty pleasure of mine because this is actually the fourth one of these that I have, and I'm hoping it's going to be the second one that I've repaired. I actually put a search into eBay looking for broken subwoofers, and the fabulous Scott, cheers Scott, came up with the goods, and I picked up this bad boy the other week, and now it's time to see if I can make him work. Unfortunately, probably should have had a bit of a tidy up in here, but it's too exciting, so let's get going. The lights are on down here. I'm putting this fabulous waveform into it, but absolutely nothing is coming out. Now my suspicion is we're going to need to replace this guy, which is the standby relay, but we'll come on to that in a sec. First of all, we're going to have to take the back off, so for that we need a little hex screwdriver, so give me a second and I'll pop that off. Alright, so I've popped out all of those screws. Just do make sure you only take out the hex screws from round the outside, otherwise you could end up in a bit of a pickle. Then grab a good tight hold of it because it's quite heavy, and then you can lift it out. And now you can see this black and red wire that connects to the actual driver, so we need to take that connector off just in there so that we can get on with working at it. First thing I want to check out is the main cone itself. So I've wedged my probes and my multimeter in there, and I'm looking for 4 ohms, and I've got 3.7. So very happy with that. It means my main driver cone is in good shape, and it means we should be on for a good repair. So that means we can now dive into the really nerdy part. Now you can see I've wedged this thing up, so it is nice and wobbly. Underneath you can see where the power comes in. Now they've tidied this up with lots of heat shrink to keep it safe. So I think when you're working on this, although you need to be quite careful, you're probably not going to kill yourself.
Hey, what's most exciting is that I found a schematic for this bad boy. Now I actually searched in the end for something called a PC12, and that led me to the service manual for the woofer. Now I think the PC12 is actually some kind of surround sound system, but I haven't had a good look at this. I'm pretty sure this is the right schematic or close enough. So let me give you a really interesting wander around this schematic. At the top left of the schematic here, you can see the input stage to the system. These connectors here are the phonos that allow you to connect audio or low-level signals, and down here this is for the full speaker connector. That then goes in through a buffer amp into this filter network. Then this is the part that allows you to select the cutoff frequency, forms a second order filter with this op amp, through another buffer into this guy here, which is yet another buffer. This guy flips the phase of the signal, inverts the signal, so you can select the 0 or 180 degree phase. Now, slightly annoyingly, any kind of analog filter that you build also messes with the phase, usually by somewhere between 0 and 90 degrees, which is quite annoying. It really is unavoidable, but it means that wherever you set this guy, the phase is going to be slightly out, unfortunately. Nevertheless, that will go through this volume control here to set the level of the sub, wanders through here, along across the connector, into this part here. Now, this input stage here, that maps to the board you can see at the top here, and you can just see how the connections wander through the back panel to the part that you can twiddle with on the back of the woofer. Okay, so the audio signal from the little board comes across the connector and runs into this part of the circuit, which is the main amplifier. This is a pretty conventional analog amplifier, boosts the signal up to 150 watts. I'm really hoping that we don't have to dig into anything and that this part is actually working all right. I will point out over this side, this is another relay, the second relay in the system. This is the anti-thump relay, which his idea is to stop when the system powers up. The voltages are all a bit of a mess. and so you want to wait for the system to settle down before connecting the loudspeaker. That's what this guy does. A little time delay before actually connecting the main driver cone. Part to look at is this section here. This is the power supply to the system. Now this is a really old school conventional power supply. Big transformer. That's the vast lump of metal you can see on the back there. Now this, nowadays you would use a switch mode power supply, which works very differently and is much more efficient. And what's more, since this is the only transformer in the system, it means that this huge transformer is powered the whole time, even when you think it's actually in standby. And my guess is that it's churning through something like 5 or 10 watts, doing absolutely nothing, which is not brilliant in this day and age when we're trying to save the planet. And since I've got 4 of these bad boys, I certainly won't be using the auto standby, despite the fact that it's the part that I'm most likely to be repairing today. To have a wander around is down here, and this part of the circuit is the bit that works out whether you actually are in standby or not. Basically, it takes an audio signal from the input stage and does some bits and bobs to it, and then it ends up down at this transistor. Now, basically what happens is when the audio goes above a certain noise level, obviously you want to come out of standby because you're going to listen to some loud and raucous music. So to control that, basically we have this relay. Now the deal with a relay is that you draw current through it using this transistor. Transistor is basically a switch, so you can either switch current through it or not. And as you pull current, if you follow the dotted line, this hopefully takes us up here, it controls the state of this switch, which sure enough is right in the line of the power rails to the main power amplifier up here. Now, interestingly, and something that took me a while to get my head around, is that this relay works in the other way than you might think, in that it is powered when the unit is in standby. So it actually pulls the relay contacts into the standby state, which is a little bit unusual, but nevertheless, what it does allow us to do is actually to test out this relay quite easily, because when we're unplugged and there's no power in the system at all, the unit should have a connection between the inputs from the transformer, across the fuses, which obviously we need to check as well, through the relay and into these diodes, which then take the AC and make it into DC. And these diodes and the fuse, they're all on the top of the circuit board, so it's really easy to find those and to ring them out, see if they're connected. And one last thing to say, the way this guy is wired, basically when you come out of standby, you need to, or the system has to recharge these big capacitors. And that's really, in my book, is the reason why these relays keep crapping out, because as you charge the capacitor, it takes this huge surge of current, probably in the tens of amps, through this relay as it's closing, and that causes the contacts to burn out, and that's how come the units fail. So that's basically my hunch as to why there's been a few cases of these relays failing, and why it's a prime candidate for your woofer not working.
I've undone this screw here. It's got like a little retaining bolt in there, so it's reasonably straightforward. And there's a little tie wrap down here that I've snipped. But do that carefully, because if you cut one of those wires, you'll be in a bit of a pickle. So I'm pretty sure the easiest way to work on this guy is to take the transformer, this big guy here, off of the main back plate, and that's done with these screws here that actually go right in between the vanes of the heatsink. So I'm going to undo those and move that transformer out of the way. Right, so everything is now at its wobbliest. I've just had a little trace through, and basically make sure the power is off. I've set my meter up to beep if I have a connection, and so the power goes in here through the fuse, goes into the relay. Now I can only get at from underneath, but to save you the bother, I've traced it through, and this side here comes to this diode here, and that is not connected. And the bottom one here comes to this nearer diode here, and that is also not connected. So that is, to my mind, still pointing to the same problem. So next I'm going to pop off this relay and swap it over. Okay, now this is the fiddly part. What I'm going to do first of all is add a teeny bit more solder on. This is just to make sure that, because sometimes they use cheap solder on these that has quite a high melting point and it can be a bit fiddly. Now I'm going to try and clear the solder away from each of these connections with this beastie first of all. And so I'll pop it on there and shoot, and that's not bad. And it pulls the solder away, making it just that bit easier to get the thing off. So I'm going to do that 8 times. I probably won't show you them all, and then we'll see what we get to. If you don't have the solder sucking gizmo, I'll just show you this stuff, which is pretty cheap. It's a sort of copper braid, and if you put it on the joint and then pull it along, it slurps up the solder, clearing it away. And this is really quite an economical way to clear the solder off and loosen it all up. Okay, so if I see if I can get a nice pick there, you can see the solder is reasonably clear and everything wiggles, and I can just pull this guy off at the back. There we go. Don't know if you were watching closely, you might be able to spot that actually the one that I took off, this blue guy, is a little bit different to the one I'm proposing to stick on. I can't for the life of me explain why. It might well be that the last time I did this, there was a different part on there, and so when I replaced it, I got a slightly different one again. But anyway, I'm pretty sure that the pinout will be the same, so I'm going to stick it on anyway and see what happens. Okay, so here's a nice close-up of the relay that I took off, the Good Sky MISH224L in fact. And here's a screenshot from the one that I bought. I'm quite liking the sound of the Potter and Brumfield. Somehow seems to have a nicer ring to it than the Good Sky. Anyway, this is the one that I put on and it seems to work fine. Mere £5.73, available from Farnell. Okay, I've slotted in. I'll just show you here. Basically, I've soldered one connection on because you end up with this problem where everything's wobbly. And so I've made sure the one is on, and then I can push that in, make sure everything's sound, and then I'll solder the rest of these contacts on. Okay, now it's time for the big switch on. So first of all, I popped everything back together, put the transformer back on. It's a little bit fiddly because it's quite heavy to get, difficult to get all those screws in. But you know, reassembly is a reverse of disassembly and all that. So if you've got this far, you should be able to get that back on. So now I'm going to switch it on. And you might have just heard a second click there, which I'm really liking the sound of. That guy is what's called an anti-thump relay, which is a bit of a twazzy name for a little relay, the second relay here. And that waits a second or two for everything to settle down before it actually connects the main speaker. And it just stops it all going woof when you first turn it on. So now I'm going to hit the audio. Oh yes, get in.